The only thing more fun than math is more math. We thought we'd give you one bonus example here. We are going to determine the equation of a transformed function. Now, this example is not in your workbook, so don't panic. But we thought we'd work with something a little bit familiar, like a parabola, and then load it up with transformations and see if we could find the equation in terms of x. You might want to stop this video right now and see if you can find it on your own first. So f of x is described as, or defined as, 2 times x plus 1 squared minus 3. We are going to construct a transform function by stretching vertically about the x-axis by a factor of 6, reflecting in the y-axis, translating 4 units right and 5 units down. We'll start by writing this as a mapping rule. Our vertical stretch by a factor of 6, our reflection in the y-axis, the negative sign, our shift 4 right and 5 down. Now, in order to write this in terms of f of x, we need to determine our parameters. The vertical stretch gives us a coefficient of 6. We will subtract 5 at the end outside of the brackets because of our translation. Our reflection replaces x with negative x, and then our translation 4 right replaces x with x minus 4. So, let's see our equation in terms of x. It's important that we apply stretches before translations within each direction, which is to say, it's okay to apply a vertical translation before a horizontal stretch, but not a vertical translation before a vertical stretch. So the first thing I'll do is I'll multiply my entire original function by 6. This is the vertical stretch of 6. Then I'll subtract 5. In order to represent our two horizontal transformations, we'll be replacing x with the negative x minus 4. This gives us g of x equal to 6 times 2 bracket negative x minus 4 plus 1 squared, subtract 3, minus 5. Wow. Let's clean this up a little. The 6 out front distributes to both the 2 and that negative 3. That takes care of the square brackets. Within the circular brackets, the inside brackets will distribute the negative sign to both the x and the negative 4. At this point, it's probably easier to follow, but we've added the 4 and the 1 to make the 5, and we've added the negative 18 and the negative 5 to make the negative 23. Now I'm going to divide out the negative sign in front of the x, which makes it negative negative 1 times x minus 5, and I apply the exponent of 2 to both of those factors. Because the negative sign is really negative 1, its squares become a positive 1, leaving us with 12 times x minus 5 squared minus 23. So how do we go about verifying such a complicated question? Well, we do have the equation of the original function, and we do have the equation of the transform function, and we do have a graphing calculator. Let's go ahead and graph f of x and g of x. We'll need to adjust our window a little bit, as g of x has its vertex as low as negative 23. Whether we use the equations, which are in vertex form, or we use the second calc minimum function of our calculator, we can determine our vertices here to be negative 1, negative 3, and 5 and negative 23. Let's see if the vertex at negative 1 and negative 3 lands on 5 and negative 23 using our mapping rule. We replace x and y with negative 1, negative 3, and are happy to find our anticipated result. This strategy of using your graphing calculator to check your answers can really increase your confidence, much more than flipping to a back answer page. Knowing that you got it on your own and that it is correct can make you feel great. This is a tough question. If you got this, well done.